Next, we're going to configure Dynamic NAT and Dynamic path. So configuration steps is going to be that you define the interfaces, likewise as inside outside NAT. We have done that already. Then you define what traffic to be translated via an access list. Because with Dynamic NAT in general and Dynamic path, you're going to translate your inside host, pretty much all of them, into one or fewer IP address to get internet access. So you're going to be, because you may not want to to NAT all of them, you're going to define in an ACL who gets NATed. And you can use standard ACL or standard ACL, it's up to you. And then you optionally define an IP pool of translated addresses. Like into what do you want to translate those hosts from the inside. Now I said optionally because if you do path in one of the router's interfaces, you don't have to define a pool. And then of course in the end you configure the dynamic NAT path rules. So the pool is optional because as you're going to see, what we're going to do is we're going to translate VLAN 11 as traffic goes out on the internet. We're going to translate VLAN 11 into the IP address of router 1 on the outside interface. So if that's the case, I'm going to translate all traffic into router 1's IP address on that interface, which means I don't have to create an IP pool to define into what do I want to translate the inside hosts. Verification steps are going to be the same. You verify the NAT interface and NAT type with IP NAT statistics. But likewise, in most cases, you're going to be forced to say show run section IP NAT to see the actual NAT configuration. Show IP NAT statistics is pretty much good to verify what is your inside outside NAT interfaces. So what are your inside and outside NAT interfaces? And also to identify what kind of NAT you have configured, but not the actual NAT configuration, as you saw with static NAT as well. And likewise, you verify the translation entries in the NAT table with show IP NAT translation. So now what we're going to do is, initially, we're going to perform before I do that, let me go on this switch in here, which is between PCA and router 1, and make sure that on this ports in here I removed the IP source guard because I'm going to change some IP addresses. And also let's make sure I removed pretty much that's going to be the IP source guard. On switch 1, let's verify that up. It is removed, and on FA105, here we go, let's change that because it's going to drop the packets. Show IP verify source. Okay, source guard is disabled now, IP source guard. Now looking back at our diagram in here, so now what I'm going to do is I'm going to pretend that I have no public services available in my network. I just want to provide internet access for users in my VLAN. Likewise, this being the inside NAT interface because it's facing the inside, and this being the outside NAT interface because it's facing the outside. And I'm going to first do dynamic path, and I'm going to choose to NAT all traffic. So as traffic is sourced with 10, 10, 11, 0/24 and goes inside outside, I'm going to choose to NAT all of those all those sources. All of my VLAN 11 is going to get NATed into a source of 136.1.31.1, which is the IP address of router 1 from the outside NAT interface. So I'm going to start with with path or NAT overload or dynamic path. So let's go on router 1. First, remove that static NAT configuration for PC. And so first I got to say, what do I want to NAT? VLAN 11. Let's match it in a standard ACL. So let's say IP access list standard NAT ACL. And say permit 10.10.11.0/24. This is what I want to NAT. Then this is the source addresses I want to NAT. Then I know into what I want to NAT, into the IP address of router 1. So the last step is going to be to just actually configure the dynamic path in there. So I'm going to say IP, likewise IP NAT inside source list and the ACL name. So I'm saying if I want to perform IPv4 NAT for the inside hosts, I'm going to do a type source. If traffic matches that list, I'm going to NAT it into interface gigabit 01 overload. So I'm saying that all traffic from my inside NAT interface, which matches that ACL, I'm going to source NAT all of that traffic into the IP address of my gig01 interface, and overload means I'm going to port that as translate all of them. If you say show IP NAT translations, because this is a variation of dynamic NAT, there's nothing active in there, because as I stated, the traffic has to show up for translations to be done by the router. The router has to see traffic flowing inside outside, which matches that ACL, in order to NAT all of those sources into that interface's IP address. So let's go again on PCA and telnet to router 3, which means I should get NATed into the IP address of router 1's gig01 interface. Let's go on PCA. And telnet to 555.3. Cisco, and who I should see that I'm being visible on router 3 is 136.131.1. And there we go, that's the case. I'm visible as 136.131.1, which is router 1's IP address, because I'm NATing all traffic into router 1's interface IP address. If you go on router 1 and say show IP NAT translations, there we go. Right now I see a NAT entry which states that PCA, or the source random port number, was NATed to, the port number was skipped, but the IP address was changed to the IP address of router 1 as expected, and destination remained unchanged because I'm not doing destination NAT. To confirm that, I can of course do I can NAT the whole VLAN 11 in the same address of router 1. Let's go on PCA and change the address statically. Let's put on PCA an address of .200 statically. Initiate some traffic to see that it's still going to work. So let's exit, and I should also still get NAT again into the same address. Change adapter settings, lambda recognition properties, and let's put a static IP address. Properties, use the following IP. Is going to be 136.10.10.11.200 with a mask of /24, and of course the default gate is still going to be router 1, and that's all I need. Okay, so now I should be able to telnet again, but this time I have an address of, on PCA, of 10.10.10.11.200, which, because it's still in VLAN 11, its traffic is routed out by router 1. It's going to again change the source to its IP address in that gig01 interface, 136.1.31.1. So let's say CLS, and let's telnet again to 555.3, not 5553. Telnet 5.5.5.3. Cisco who I should again still be visible as 136.131.1, and there we go. And if we look in Router 1's translation table, we should see that also the IP address of 200, the new address of PCA. So it behave. I've configured this to show you that, of course, all the IPs in that subnet can be mapped clearly in that single IP address because I'm doing port address translation. So this is like it's a new host in that VLAN, which again also got added to the same address in there. Okay. Now let's do dynamic NAT, which means I'm gonna choose to NAT all that VLAN. So as traffic is sourced with 10.10.11.0/24 and gets routed out on the internet, that's a /24 subnet. I'm gonna choose to NAT those sources into a pool of, let's say, one IP address, but of two IP addresses, 136.1. Actually, let's put one IP address, .31. Let's say 200. So I'm gonna NAT everything in a pool with a single address. Let's put two addresses, 200 to 201. But what I'm gonna do in here is gonna be a dynamic NAT configuration, not dynamic path. So because it's dynamic NAT, it's gonna be a dynamically built one-to-one mapping. So let's do that. So we go on router configuration, we remove that path configuration, and we have to configure the pool. So I'm gonna say IP NAT pool, give it a name of dynamic NAT pool, and start IP address 136.1.31.200 and IP address 136.1.31.201. So I have two addresses available in the pool. Prefix length, it has to be, make sure you don't put something lower than 30, don't put something higher than 31. Let's say it doesn't matter, /24, for example. Fixed length 24. So I want to NAT all traffic into those IP addresses. My traffic is matched by my XCL, my pre-configured access list of this, which means I want to say IP NAT inside. So I'm going to say I'm going to perform NAT for IPs on the inside. For source IP of traffic received on the inside interface. I'm going to perform IPv4 NAT for source addresses of traffic received on the inside interface. If traffic matches that list, I'm going to NAT the sources into the configured pool. And I'm not saying overload because I don't want to do path. I want to show you the dynamic NAT, which is still a one-to-one mapping. So show IP NAT statistics. I still have, of course, the inside NAT, outside NAT interfaces. It tells you that that ACL is being mapped in that dynamic pool, so it gives you a bit more information, and also shows you what is the pool content, how many addresses you have in the pool. And currently we have 2 addresses in the pool, and none of them have been allocated, which means in the translation table I should see nothing in there, because likewise this is dynamic NAT. Traffic has to show up to be able to see something in the translation table. So now currently PCA has an address of .200. So let's initiate traffic out on the internet, which means it should get assigned the first available address from the pool, which means .200 as well. So the address of 10.10.11.100, 200, because that's the address of the PC now. As traffic goes out on the internet should be NATed to 136.1.31.200, because that's the first available address from the defined pool. Let's confirm that. From PCA. That was something which pre-existed because I said exit in there, SharpNet translation. Let's start fresh now. So let's say CLS, and let's tell it now to router 3. CISCO, CISCO. If you say who, I should have been assigned the first address from the pool, and there we go. This is the active session, the one with the star, which I am visible as the first available address from the pool, 136.131.200. If you look in the NAT table of router 1, you should see exactly that the PCA got assigned the first available address from the pool, and of course the other entry is the extended translation entry, matches the actual traffic flow from PCA real address, which got netted, to router 3's loopback. Now if we change PCA's address into, let's say, .50, for example, it means it's like I'm gonna have a new host on that subnet. I'm gonna change the address of PCA, which means it's like I have a new host in that subnet, 50. Okay, close. So now is PCA, which is now 10.10.11.50, sends traffic out on the internet, it should be assigned the next available address from the pool, which is 136.1.31.201. Let's confirm that. Before you do that, if you go on router 1 and say show IP NAT statistics, it's going to show you that currently I have allocated one address, 50% of the pool, and I have one left available. Okay, now let's go on PCA, which is a new address of .50, and let's tell it again to router 3. CISCO, CISCO. If we say who, there we go, the active session, which is this one, I'm visible as the next available address from the pool, which is 201. If we go on router 1, as we look in the translation table, as expected, that address, the old PCA, which was assigned that address from the pool, .200, and this new host from the segment from VLAN 11 got assigned the next available address from the pool, .201. And that defines the flow traffic from the new host 10.10.11.50, which got netted to 136.131.201 as traffic went out to the loopback of router 3. Now if you look at the statistics entry, then at this point I have two available addresses in the pool, and both of them are assigned. I have no more available address to NAT traffic into. So let's go on PCA and change the address of PCA to be, let's say, .80 now on that segment. So PCA is going to have a 10.10.11.80, and let's see what happens now when PCA sends traffic out, because there is no more available address in the pool to translate that address into. Let's go to PCA and change the IP address in there, properties, to be .80. Let's open up a new terminal session and say telnet 55.3. If we go around and say show logging and say debug IP NAT, and we try to telnet again, translation failed, dropping the packet source from PCA as expected. So now what happens is PCA initiates traffic sourced with 10.10.11.80. Traffic reaches router 1. It matches the NAT configuration, which means router 1 is configured to NAT that traffic. It matches the NAT config. But because there are no more available addresses in the pool, because the pool had 2 addresses and they have been assigned, then NAT fails. NAT fails. So router 1 drops the packet. That's what we see in here. That router 1 dropped the packet, and that's why Telnet 2 router 3 doesn't work now from PC. And that's by design and is expected. So Dynamic NAT is still a one-to-one mapping, which means you got to make sure that if you have on the inside LAN 200 hosts, your pool should be also 200 hosts. Because otherwise, if you have on the pool only 100 hosts, then after the 100 IPs have been assigned to the first 100 hosts from the LAN, then the remaining 100 hosts from the LAN are going to have no more IP addresses to get assigned from the pool, because the pool is depleted, and they're not going to be able to send traffic out on the internet. So dynamic NAT means that you got to make sure that what you want to NAT, the source, like if it's a stationary 4, you got to make sure that the pool is also a stationary 4 for one-to-one mapping binding to work in there. Otherwise, you may run into this problem, and it's not something that clearly you would want this to happen. But of course, now if I change this configuration on debug all, if I change this config to NAT overload, well, of course, I'm not going to redo the example because I got to clear the mappings. But if you do overload, it means I'm going to path all traffic matching that ACL into those IP addresses from there. So if I do path, of course, clearly it's going to work again, because I'm no longer going to assign. I'm no longer going to do a one-to-one binding in there, but I'm gonna do a many-to-one binding for each address of the pool. So path means that you're going to be able to map many inside addresses to the same translated address in there, as we saw before. And let's make sure show IP NAT translation, something else which I want to show you, and then we're done with this. Show IP NAT translation. So I have those 2 bindings of .200 of PCA, which is visible on the outside as 31.200. So let's go on PCA and put back that address of 200. Put back the address of 200. Which means now PCA should again be able to send traffic out of the network, because 10.10.10.11.200 was already assigned an address from the pool. So now when PCA sends traffic back out in the network on the internet, it is going to work. CISCO, and is visible as who? It is visible as, this is the active session. The first one is visible as .200. And now, as I stated, a dynamic NAT doesn't mean that traffic cannot be initiated both ways. As soon as the one-to-one mapping is available in translation table, it means that now somebody from the internet, like router 3, could also initiate a session destined to PCA, which means they're going to be destined to 136.1.38.31.200. And as router 1 routes the traffic to PCA, is going to change the address back to 10.10.11.200. To confirm that, let's go on PCA, start again the TFTP server, and we should be able to copy that file again from router 3 as the TFTP client. So because the TFTP client is going to initiate that session back to the server, the control plane session, This is going to confirm that, of course, Dynamic NAT, which does a one-to-one binding but dynamically, it is going to allow bidirectional traffic to be initiated as soon as the binding is being done, shows up in the table. So let's go on PCA, start the TFTP server again. Looks good. So let's go on route fee. And I'm going to copy, this is the address of the TFTP server. I'm going to say copy TFTP. That any file to null 0. To null. And there you go, it worked as expected. If you go on PCA, we see the transfer happening. And if you go on the NAT table of router 1, we should see additional entries for both the control plane station of TFTP and the data plane station of TFTP. And there we go. So traffic from router 1, router 3, destined to PCA is the control plane station, destination port UDP69. And they're pretty much, those are going to be the data plane station, because both source and destination ports are random. But of course, as I stated, if we clear the translation table, clear IP NAT translation all, which means because all of those entries have been dynamically created, show IP NAT translations. Now, if I want to initiate traffic from router 3 to PCA for the same scope, it's not going to work. Because router 3 cannot know, okay, what is the translated address of PCA? What is the translated address of PCA? It's none of it. Because router 1 doesn't have it built. Because I'm doing source NAT, PCA still first needs to send traffic out of the network so that the translation happens. So that a one-to-one mapping, dynamic binding happens. And then somebody from the internet can also initiate traffic back to that host in there.